Hi and welcome back to the CSR House Project series. So we've heard about why CSR are undertaking such a challenging project. Now we need to understand how they're going to achieve it. We've got a great contemporary design, but the aesthetic appeal of a house is only part of the story. A home needs to provide shelter and be a comfortable place to live. With rising utility prices, ensuring our home remains comfortable is becoming more costly unless you have a highly efficient building. With the CSR house, we're aiming for 8-star thermal comfort performance, which should use half the energy for heating and cooling than, say, a 6-star house, and approximately 80% less heating and cooling energy than the average Australian home, which sadly is about 2.75 stars. In the 8-star configuration, heating and cooling the CSR house on average should cost less than 50 cents a day.
A 0-star home is a very inefficient home. It's likely to be uncomfortable and have high energy use. A 1-star home represents a home built before 1990. A 6-star home is likely to have about 70% less energy use than a 1-star home, and an 8-star home 85% less energy use. A 10-star home is likely to have 0 heating or cooling requirements. The new energy efficiency provisions mean that a home built to a 6-star standard will use 45% less energy than a home built prior to 2003. CSR provides building products for floors, walls, ceilings and roofs which help comply with the new 6-star standards by using energy efficiency products such as insulation to make the building more energy efficient.
With the increased emphasis on energy efficiency and the complexity of compliance, you're going to need some serious software to calculate the energy rating of your construction, especially when you're going for the 8-star rating like the CSR house.
We analysed over 1 million permutations by simulating the house in 20 different climate regions with 8 different orientations across a wide range of building material combinations. Carrying out so many permutations on the building allowed us to optimise the design for different climate regions across Australia and allowed us to specify appropriate building materials for specific climate regions.
Achieving a high energy rating is not just about choosing 1 or 2 high-performing products and hoping for the best. It's about careful selection of products that perform well on their own, but perhaps even better in combination with other materials.
When we started to look at construction systems for the house, we really wanted to challenge some standard industry practices and not just build the usual way because it's always been done that way. We also wanted to examine the efficiency of various material options, such as different levels of insulation and glazing. When we started with a base house design using minimal insulation, clear glazing and basic materials, we achieved an initial rating in Accurate of just 3.5 stars. We did the calculations on other floor options, and as we had a level site, a slab on ground was a much better proposition than a post and beam floor system. We found that slab on ground was cheaper and faster to build while providing thermal coupling with the ground to improve the energy rating of the house. When we substituted the raised floor for a slab on ground, the energy rating jumped to 4.2 stars.
Throughout Australia, ground temperature remains fairly stable throughout the day and the night. The ground temperature is generally cooler than the indoor environment inside your house. This means that heat can be drawn from inside your house down into the ground. This isn't necessarily a bad thing. In warmer climates, this means that you actually get free cooling from the ground. You can do this if you use it with ventilation and you use the cool nighttime temperatures to cool down the thermal mass. And then during the day when the temperatures rise, your walls, floors and ceilings will be nice and cool, keeping your house more comfortable during the day. Heavyweight construction is very good at storing energy or storing heat. Constructions that can do this are constructions such as bricks, concrete and tiles. They can store heat when they have direct sunlight. In winter, they'll store that sun's energy, and then during the night time when the temperatures drop, they can release that energy back into your living space, reducing the amount of energy required to heat your house.
Conventional first floor construction is usually a very lightweight particle board, often referred to as yellow tongue, green tongue or even blue tongue. It's certainly pretty cheap, but is it value for money long term?
We compared the particle board solution with the suspended concrete slab and Hebel power floor. The suspended concrete slab was, as expected, the most expensive option, while the Hebel power floor had a modest premium in price compared to the particle board. However, the thermal performance of the Hebel was equivalent to the concrete slab, with a boost to the star rating of half a star to 4.7 stars. Acoustically, Hebel performs just as well as a concrete slab.
Obviously it's 50mm thicker than the particle board, but not to mention it's got better thermal properties, it's got better acoustics. Have a listen to this.
To get the really important improvements in thermal performance, we then looked at insulation and glazing.
The ceiling, walls and windows of your house account for almost 80% of all heat gain and heat loss. So insulating your building fabric can have a significant impact on the thermal comfort of your home.
We increased the ceiling insulation from R3 to R4.1 using Bradford Gold ceiling bats. We then increased the external wall insulation from R1.5 to R2.7 using Bradford Gold wall bats. These are the highest rating wall bats available in the 90mm thickness, which means we can have a standard wall cavity construction with much higher insulation levels. We also installed bulk rock wool insulation to the cavity brick wall at the rear of the house to ensure heat gain in summer and heat loss in winter was minimised through the double brick wall.
Now for most houses, this is where insulating ends. If you want to achieve an 8-star energy rating though, you have to think further than that and think about other areas of the house that would benefit from insulation.
We took the unusual step of looking at the internal walls and the mid-floor of the house, where we introduced Bradford Soundscreen rock wool bats. Most people associate these with providing acoustic insulation, but they're actually a great thermal insulation as well. So you not only get a quieter house, you have better control of the temperature within. If your internal walls are insulated, you have the option to close off whole areas to keep warm in winter, or even to open doors to vent the heat in summer. With these 3 insulation options, the star rating of the house jumped a whole star to 5.7 stars.
Upgrading your insulation to this level should only add about 1% to the total house construction costs. For all the money you'll save through insulating your home, that's a worthwhile investment. And then when you improve your glazing...
The first step in upgrading the glazing options was to look at a conventional window frame system. For this, we chose the Trend Quantum range of windows. By replacing clear glass with Viridian Smart Glass, our window U values went from 6.2 down to approximately 4.5. With windows, the lower the U value, the better the insulation levels. This combination gave us a boost of 0.7 stars, up to 6.4 stars for the whole house. As always, we were looking for ways to improve on that, so we then looked at the range of thermally isolated window frames. Trend's Thermal range of window frames is a breakthrough in high-performance window systems. The Trend Thermal windows use double-glazed units as standard, so not only do you get a much better performing window frame, you get better performance from your glass. The entry level for double glazing is Viridian Thermotech toned glass, so with the total window system now achieving a U value of around 3.4, we were able to achieve a rating of 7 stars.
7 stars represents a whopping 70% saving on your annual heat and cooling energy costs. Now that's going to add up over the life of your home.
Getting to 8 stars was a little bit trickier. We introduced a low E coating to the Viridian Thermotech double glazed units, along with argon gas to the space between the 2 panes of glass. The Viridian Thermotech low E units in the Trend Thermal windows resulted in a U value of just 2.6.
This got us to 7.7 stars, but it didn't quite get us to our goal of 8 stars. We looked at the orientation of the windows and the amount of glazing on the north and south of the house. This was to ensure that we didn't get too much heat gain in the summer and too much heat loss in the winter. This process resulted in us reducing the amount of windows on both the north side and the south side of the building. In total, we reduced the window area by 7 square metres. This left us with 58 metres squared of glass in total in the whole house, which is still more than the average home.
After hundreds of hours of research and thousands of calculations, we've achieved 8.1 stars. These final calculations have been independently verified by 2 energy assessors in both Accurate and Burrs Pro software. And when the house becomes CSR's R&D centre, at the end of the building process, we'll look forward to verifying these figures with our own collected data.
When you see how much you can save by upgrading your home's energy rating, it just makes sense for the environment and your bank balance to explore how you can improve on the standard 6-star rating. If you'd like more information on any of the products we've talked about today, you can visit csr.com.au and follow the links to Hebel, Bradford and Viridian or trendwindows.com.au. For more progress on the CSR House project, check us out on YouTube or csr.com.au. Hope to see you soon.